Every system is designed with a purpose in mind. But over time, many systems continue behaviors that actively work against that original purpose. This isn't usually an accident. It's often a result of the system's own structure.
So that brings us to the central question. Why does this happen? We have this basic assumption that systems will adapt when their environment changes. But what we often observe is something quite different. They become rigid and resist the very changes they need to survive.
And this is the core puzzle we're looking at. We expect adaptation, but what we get is persistence. The system tends to stay in a particular state, even long after that state has stopped being optimal.
To really understand this persistence, we have to go back to the beginning to see how a system's path gets set in the first place. The seeds of future rigidity are often planted right at its formation. The key concept here is called path dependence. What this means is that the choices made in the past end up constraining the choices that are available in the future. History matters, and it narrows the field of possibilities. A system's path is often shaped by decisions made during what's known as a critical juncture. This is a formative period where even small, seemingly random events can push the system toward one specific way of doing things, which then tends to stick.
And once that early choice is made, it sets the system on a distinct trajectory. By selecting one path, all other potential paths are, for the moment, excluded. And this is where a process of self-reinforcement begins. So once this path is chosen, some pretty powerful forces start to lock it into place. These are the mechanisms that make it harder and harder to deviate from that established course as time goes on. The engine driving this lock-in effect is a dynamic called increasing returns. You can think of it as a positive feedback loop. The more a path is used, the more beneficial it becomes to keep using that same path. Here's how the loop works. First, every time the established process is used, people learn more about it. They find small ways to refine it and make it more efficient within its own narrow framework. And of course, a more refined, more efficient process becomes more attractive to others. So new users adopt it, which further reinforces its dominance and makes any alternatives look less and less practical. The cycle just gets stronger with each turn. There are a few specific factors that really strengthen this lock-in. First, you have large setup costs, which create a high barrier for any competing alternative. Then there are learning effects. People have already invested time and energy into learning the current system. You also get coordination effects. Switching to something new is only worthwhile if everyone else does it too. And all this leads to adaptive expectations, where everyone just assumes the current system will continue, so they invest even more in it. The result of all this lock-in is that something that started as an advantage, a better way of doing things, slowly turns into a source of structural rigidity. Necessary changes just become too expensive to even consider. Think about it this way. The success of being the first to establish a working system, what's often called a first-mover advantage, can morph into what's been called a handicap of a head start. The very things that made the system successful in the first place now become the biggest barriers to its adaptation. This condition is known as incumbent inertia. It's the tendency for an established system to resist change, and it's a direct outcome of the system's previous success. It has become perfectly optimized for an environment that may no longer exist. This inertia comes from a few places. The system might be locked into fixed assets, like technology or infrastructure, that are expensive to replace. There's often a reluctance to cannibalize existing processes that still work, even if they're becoming obsolete. And, over time, the entire structure of the organization becomes inflexible, built to execute the old model, not to invent a new one. So, as the world outside keeps changing, the locked-in system begins to fail. But this failure is rarely a big, sudden event. It's usually a slow, gradual process of decay and growing misalignment. One way this decay happens is through drift. This is when the rules of the system don't change, but the world around them does. The rules are still being followed, but their context has shifted, making them ineffective or even counterproductive. Another mechanism is conversion. Now, this is different from drift. Here, the old rules aren't just becoming irrelevant, they are actively reinterpreted and repurposed to serve new goals that often have very little to do with the system's original mission. What's really crucial to understand is that this growing dysfunction can be almost invisible to the people inside the system. From their point of view, procedures are being followed and work is getting done correctly. The problem isn't a failure of execution, it's a failure of alignment with reality.
When you look at the whole sequence of events, from that first choice all the way to eventual dysfunction, you start to see that it isn't just a series of mistakes, it's an emergent trap, a property of the system's own evolution. There's an idea known as Gall's law, which puts it well. It says that a complex system that works has always evolved from a simple system that worked. This trap we're describing is a direct consequence of that successful evolution. The system's initial success creates the very conditions for its later rigidity. Because at every single step along the way, the decisions that people make inside the system are completely rational. They are logical choices based on the incentives, the constraints, and the information that's available to them right then and there. And it's the steady, relentless accumulation of all of those locally rational choices that ultimately produces a globally dysfunctional outcome, and that is how a system gets stuck. It's a failure that emerges not from bad intentions or individual errors, but from the very structure of the system itself.